Professor for his presentation. Let me introduce Professor over here to all audience. Professor Kadambhoot Siddiqui is presently a Hackett Professor of Agriculture Chair and Director, the University of Western Australia Institute of Agriculture. He graduated from Kerala Agriculture University in Agriculture in 1977.
So what we'll do, a short paragraph.
FVSc in Crop Physiology from Indian Agriculture Research Institute, ICR, in 1979. Then he completed his PhD in Environmental and Crop Physiology, the University of Western Australia in 1985. After completion of his PhD in 1985, Professor Siddiqui joined the Department of Agriculture and Food, Western Australia, as a cereal crop physiologist and worked his way up to principal scientist and leader of DAFWA Pulse program. He became the director of Center for Legumes in Mediterranean Agriculture at University of Western Australia in 2001 and remained in this position until 2006, when he was appointed to establish and lead the University of Western Australia Institute of Agriculture. Professor Kadambhoot Siddiqui has made outstanding contributions to agriculture in research, education, and industrial development. Professor Siddiqui's major contribution to dryland agriculture has been crop yield improvements in grain, legumes, and wheat, and the release of 13 new grain legume cultivars. His education and research training initiatives span many regions, including Australia, Asia, Africa, and Middle East. Professor Siddiqui has been awarded and he has been elected as Fellow of African Academy of Sciences for the first time from Australia. Government of India Ministry for Agriculture honored Professor Siddiqui for his outstanding contributions to global pulses research and development. He became designated special ambassador by the UNFAO for the International Year of Pulses. He was honored with a prestigious Dunhuang Award by Chinese Gansu Province government. Professor Siddiqui was awarded prestigious Hackett Professor of Agriculture Chair at the University of Western Australia, where presently he is there. I now humbly and gratefully invite Professor Kadambhoot Siddiqui for his lecture, please. Professor Kadambhoot Siddiqui, please.
Good morning, everyone, and thank you, Professor Pambori, the Vice Chancellor of the University, faculty members, and also Dr. Habibur Rahman for chairing the session, students and participants. And it is a great privilege to address you all. And first of all, I would like to congratulate the organizers for choosing this theme, Achieving Zero Hunger by 2030. With that, I will now share my PowerPoint. Can I? Share screen. Yeah, that's what I did. Which one? Blue one. Then PowerPoint. Yeah. Good. So can you all see that? I hope.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yeah, you can hear.
Yes.
So what I'm going to do is that I'm going to talk about future smart food. Some of these we have heard from the previous speakers, but I'll go in depth. So the address is about rediscovering hidden treasures of neglected and underutilized crops for zero hunger in Asia. I will try to mention India as much as I can as well. So the outline is, I'll give a brief introduction to the University of Western Australia. This is quite important, particularly for research collaboration and also for the students. Then I'll mention about the challenges on current food system and needs for diversification and its entry point. The concept and the main features of future smart food. And what do they do? Nutrition, climate change, we heard about it. Economics is so important for the rural farmers and people, and social benefits. It's nice to talk about the theory, but how to realize the potential, that's more important. We heard about the Sustainable Development Goal, the 17. Perhaps I'm afraid we may not be able to achieve that because the time is ticking on. And then I'll draw some conclusions. So I come from the state of Western Australia, which is bigger than India. And we have only 2.6 million people. So the highest graduate wage in Australia, my university, is a prestigious Group 8 university. And Perth is a wonderful place to live. This is the campus. Now I am sitting here and talking. And this is our convocation hall. This is where the Vice Chancellery. This is a comprehensive university. So there are no agricultural universities in Australia. You may be surprised, but it is good that we have all kinds of faculties or what you call colleges, so we can interact. And I just showed the Perth, the capital of Western Australia here. And people may think Perth or Australia is far away. I think it's a relative term. We are not far away because we are in the same time zone as 60% of the world population. For example, Indonesia, Singapore, Japan, China, and even with India, only 2.5 hours difference from Perth. A very biologically diverse region on the planet, so we can look at that as well. And we have a Mediterranean type climate, which I'll come back to later. Basically, wet winters and hot summer. So I'm just wearing a jumper today. Last night it was 5 degrees, not as cold as Kashmir. So my university, UWA, or University of Western Australia, has a global reputation. It's an internationally recognized university. And today we have a wonderful ranking came. I'll share with you that. We are top 100 in the world. And more importantly, we work with the industry, whether it is the agriculture industry or the medical industry or the engineering industry. This is so important that we must connect with the real world. In Australia, there are 40 universities. But the Group 8 is the elite university. You may have heard about University of Sydney, Melbourne, University of Western Australia, Queensland. So these elite universities are where 70% of the research is done. We got our Nobel Prize in Medicine in 2005. This is Professor Barry Marshall, very close friend of mine. We have been traveling together on various occasions. He's got his Nobel Prize for the Helicobacter pylori, especially the veterinary people know that the stomach-causing bacteria. He is the first person to say that it is caused by the bacteria, and he then developed the treatment himself and proven that. So he is a graduate from here. He's a professor in medical microbiology, and he's got a center called the Marshall Center for Infectious Disease Research and Training and the clinical microbiology. So wonderful person. It is good to have a Nobel Prize winner here. Our university was established in 1911, over 100 years now. The ranking, the good news is that just the ranking came out, what we call academic ranking of world universities. It is purely based on the Nobel Prize or the Prestige Academy Fellowship, the papers you publish, the citations you make. We are now 85 in the world. We were 99 last year. And that is really good for a small university like us. In a country with a smaller population, and this is so important for the staff, students, and our partners. So that was just the good news this morning came. And they used to separate life and agriculture science, and we were ranking 24, 25, 24, and in 2017, they separated life science from agriculture science, and it is good. We were 14, 14, and this year we became 17, which is really good. Making a one jump in ranking is very hard because the Chinese universities are now really dominating the world ranking. Now we are also #1 in agriculture science in Australia. So I feel very proud and privileged to lead that group of people through the UWA Institute of Agriculture. Now with that background, the institute I'm leading is basically looking at research-based solutions to food and nutritional security, environmental sustainability, and agribusiness. And that's regionally, nationally, and selected international settings. So what we call faculty, but you call colleges, we used to have something like 12 colleges or faculties. In 2012, we compressed that into 4: Faculty of Science, Faculty of Medicine, Dentistry, Health Science, Engineering, Computing and Mathematics and Physics, and then Arts, Business, Law and Education. In that process, we consolidated a lot of duplication. We also reduced the number of degree offerings so that not to confuse the young minds and the future. And I think it is working very well within that system. So the research teams we work in my institute are crop roots and rhizosphere. They come from different colleges of faculties, the leaders, sustainable grazing system that is integrating animal production and pasture system, water for food production system, food quality and human health, engineering innovations for food production, and then agribusiness ecosystem. So the concept is that you are not restricted to one college or faculty. People from medicine, engineering, law, all come in and then look at the global challenges or the big problems. As opposed to in places like India now, I see that agricultural universities doesn't work with other universities. And within agriculture, you're now seeing compartmentalization, horticulture, the fisheries, animal, and farmer doesn't look at that. A farmer has to integrate. So I don't agree with the strategy the Indian institutions has doing, that is a division and going away. If you look at in China, they are bringing universities together to work together rather than separately. Now I'm going to the topic of my talk today, the prevalence of undernourishment in Asia and Pacific. We have already heard that. So you can see that the number of undernourished people still about close to 450, 480 million. And if you look at the undernourishment in percentage, so you can see that it is still around 11, 12, in some cases up to 15%. So it is still a problem. We have not gone away from that problem. Now, you heard from Dr. Habibur Rahman about the stunting and wasting. These are two indicators of the well-being and nutritional status of particularly children under 5 years in the Asia and Pacific region. And the point again, Dr. Habibur Rahman and others have mentioned, India is still very high. Look at that, India. India is sitting around close to 40%, 35 to 40% of the children under 5 are undernourished, because they will never develop the cognitive development and so on. So the one with the category 10 to 20% is shown, and the one with this orange color is 20 to 30%. So we are pretty high, and there are other countries in the region, in that South Asia and some of the Oceania region. Incidentally, being an animal production professors, they mentioned that animal protein is important. Look at that, Mongolia. Mongolia is not a very rich country, but they do rely quite a lot on animal products. And you can also see in China has brought it down comfortably over the years, and countries like Thailand, Sri Lanka, and all have done extremely well there. Wasting is another one. Again, we can see that India is #1 there in the 2015 figures. That's an alarming one, and again, close to 22, 23% is very high. And so in the South Asia, then Sri Lanka, Papua New Guinea, and so on. Again, you can see Mongolia and China has done extremely well. Now, what are the challenges for the current food system? And I'm going to argue for the needs for diversification and entry point. Where can we enter? This graph is slightly small, but just to illustrate the point, we just mentioned about the number of malnourished children. The climate change is happening, whether it is the drought, flood, etc., is on the increasing side. The biodiversity is on the declining side. The number of crop species now is so uniform. And in fact, the modern agriculture has a convergent evolution of the varieties, which is also not sustainable. We heard from previous speakers, the population has grown, and particularly in the Asia and African region. Water stress is happening, especially India, look at that. It is absolutely in red color. Soil erosion and degradation is happening. Again, you can see India has got huge issues too. The other driver is the changing dietary pattern. People are moving away from rice and wheat, now more milk, eggs, animal products, fresh fruits and vegetables, which is healthy. So we need to think about investment in major cereals by research and development organization. We need to think about investment driven away. Yes, it was good when we were looking for food security in the 50s and the 60s and 70s, but now things are changing. So as research and development has to change. We heard so much about the Sustainable Development Goal. I won't go into the detail. As you know that 17 are there, and 2030 can we achieve? I'm really concerned that we could debate about it, but having said that, we have to work towards that. Of that, I bring your attention to two. One is the number one and number two. One is zero hunger. Then number two is good health. They all go hand in hand. In fact, all the 17 SDGs has got agriculture can contribute to that. But I say nutrition essential to achieve the Sustainable Development Goal. So that's what the theme of my talk. This graph is a little bit small, but basically it shows the stunting and wasting in percentage and the stunting in percentage. Again, the point is that you got South Sudan, Djibouti, and India is on the top there again. So something which the government of India has to work very hard, and not only government, we all have to work in order to bring that down. So, but about 50 countries in the highest percentage of children suffering more than half is in Africa. So if you take 50 countries in the world, so we can't forget about sub-Saharan Africa. So India is on the third list. That is really something we have to work towards. I won't go into the details, but there are figures around Andhra Pradesh, Bihar, a number of places, but you can see that the percentages are very high in many parts of India. But if you look at the stunted children, the lowest is in Kerala, the highest is in Uttar Pradesh. Wasted children, Sikkim has the lowest, Andhra Pradesh has the highest, Mizoram, underweight children, lowest, and Rajasthan highest. Anemic children, Kerala, the lowest, still 48.5%. West Bengal, 86.4%. Anemic women, very important. Kerala is 32.7 and West Bengal is 76. So basically north, west, east, central and south, we need to look at that critically. This is again data from India only. Again, you can see that the north, west, there are patterns emerging. For example, the western part has got 19.2 wasted, and the central part got 61 or 73.4% anemic women. And so the regional differences are there, and what can we learn? So the northern states are least affected in wasted and anemic children and anemic women than other regions. Western state is home for a high percentage of wasted and underweight children. East and northeast states, children are the least affected by underweight. And central states recorded the highest value for stunted and anemic children. Southern states, children are least affected by stunting. So there is some pattern. I think more research is required. What is required? Can we learn lessons from one part to the other part of the country? And then what remedies are there to rectify? It's a wonderful data by V. Rajagopal. Now let us look at the world ranking. Again, one of the speakers mentioned how India is positioned. Let's look at the prevalence of stunting, 38.7%. We are ranked 114 out of the 130, just placed between Chad and Zambia. Prevalence of wasting, 15.1%, 120 out of the 130, in between Somalia and Eritrea. Women anemia, 48%, again, 170th rank above the 185, Niger and Guinea. Adult overweight obesity, someone mentioned that, 22%. We are not that bad, 21 out of the 190 between Malawi and Madagascar. Diabetes, India is the capital of diabetes. Although the value is 9.5, 104 ranking of the 190, Honduras and Afghanistan. Excluding breastfeeding, India is doing well there, but we could do more. 46.4%, and 48th rank out of the 114 between Gambia and Sudan. So it is clear that India is placed in dismal ranks in most of the indicators. Now moving on, hunger and malnutrition in selected countries. I'm showing you here an example of the prevalence of overweight in children and adults and prevalence of obesity among adults 2011 to 2015. You can see the figure. The adult overweight is an issue in some of these countries: Cambodia, Laos, PDR, Myanmar, and Nepal. Then if you look at the prevalence of micronutrient deficiencies, you can see that's already happening. Anemic children, anemic women, and pregnant women. You know, it's hovering around 35 to 50% in those countries, again, including Nepal. The other point is, again, the data from low production diversity. This is so important. If you look at the pie chart, you can see that Cambodia, 75% is coming from rice, the total calories. Laos, PDR, 90%, Myanmar, it is 50%, and Nepal, it is 50%. So for many years, agricultural policies have been in favor of staple and cash production. As I mentioned, rice, wheat, maize. I think it was okay at that time. Now we have to rethink about it. Our intensification of single crop system, achieve higher yields of staple crop such as rice, wheat, and maize has long been a single focus to reduce hunger without targeting micronutrient deficiencies. And also we have seen recent growth of cash crops such as sugarcane, particularly in India, and cassava in Africa has accelerated the low crop diversity farming system. The next one is food supply per gram per capita. So basically, I won't go into the data. You can see that in the case of Cambodia, 75% is coming from cereals. In the case of Laos, PDR, 82%. In the case of Myanmar, 67%. And in the case of Nepal, it is coming about 72%. So the conclusion is that over-reliance on very few cereals, mainly rice. Consumption of vegetables and fruits remains low. And in a vegetarian country or vegetarian eaters, then it becomes even harder. No animal protein get into the food system. So malnutrition and dietary diversity and production diversity. So let us look at basically lack of agricultural diversification leads to high prevalence of hunger and malnutrition. So we need a holistic and cost-effective intervention. Okay, you may argue, can I do the biofortification or can I do the supplements? How many people can afford to have supplements from a GP, general practitioner, or medical professional? So malnutrition, lack of production diversity, dietary diversity, they are all interlinked. So if you are going to design a system, one need to look at that. Let us look at that. Why we need diversity, production, and nutrition? So there are two things I want to emphasize. One is the production gap. The other one is the nutrition gap. And this will promoting agricultural diversification to address the above two gaps, the current agricultural and food system in any country. For example, doubling yields in 2050, let's say we want to increase the yield, require annual yield growth rate of more than 1.7%. But crop yields or partial factor production of land, water, fertilizer, and labor not promising, because during 1989 to 2008 period, global yield growth rates of maize was 1.6%, rice 1%, wheat 0.9%, soybean is 1.3%. It is insufficient for meeting the future food demand without having to convert a lot more land into agriculture. We know that it is impossible to have new land for agriculture. We're also seeing some of the farm yields are approaching economic upper limits in highly productive areas. In major irrigated wheat, rice, and maize system, yields appears to be near 8%, 80% of the yield potential. So there is still production gap, but we need to think about how we can increase the productivity. Increasing the production of staple crop is not enough to accelerate the reduction in malnutrition. So the nutrition gap, we heard earlier, I mentioned yield gap. The gap between what food we are grown and available, what food are needed to healthy diet. It requires increasing availability and access to the food necessary for a healthy diet. So the conclusion is that there is insufficient supply of nutrient-rich food. Yes, we got a lot of calories coming, but that's not enough to have hunger and malnutrition or stunting and wasting corrected, particularly say 35 to 40% of the children under 5 who are the future of your country or any country, and they will never develop their cognitive development. They will never become the leaders of the country. They will never drive the intellectual horsepower required for the country to move forward. So investing in those children is most high priority than anything else for me as an agricultural scientist. Now, when we want to look at the future food, and then the point is to restore agro-diversification in the food system, whether it is in Kashmir or in Australia, we can say there are 30,000 edible plant species in globally, of which 7,000 crop species have been used so far. But of that, I would say 150 crop species are commercial cultivation. 90% of the energies in human diets come from about 103 crops. If you look at the main species, there are 62 crop species, of which rice, wheat, and maize, and potato dominate. I hope my slides are legible and my voice is audible. The
Yes.
future smart food, thank you. The future smart food concept and main features. So people talk about neglected and underutilized crop, minor crops, orphan crops, promising little used crops. These are mostly wild or semi-domesticated species adapted to local environments. These traditional foods were in use for the centuries, but increasingly become forgotten when more productive, profitable cash crops are coming and replacing the farming system. People often call them neglected and underused species as they only play a marginal role in current farming system. So 4 points. Point number 1, there must be nutritionally dense, if you want to call them as future smart food. They must be climate resilient, so that we heard about the climate change, so they are adaptable to the local farming system. And no point having no economics, because the farmers are not going to grow. It should be economically viable and locally available and adaptable. So there are the 4 dimensions of the future smart food selection criteria. But the problem is future smart food is the change for perception of this neglected crop is important. And they need to get into the healthy diet, good for children, youth, and the future. But there are a number of constraints, policy constraints. So for example, the government is not promoting, and they have been giving subsidies to the main crops in order to increase production of main crops. There are technical constraints. You take your own university or my own university or the ICR system, too many specializers and too many staff working still on rice and wheat. Yes, it's important crop, but the other crops are neglected. Market constraint, because the market is not coordinated. There is demand, but there is constraint. And of course, institutional constraint. As a director of an institute or a vice chancellor, the constraint is, okay, you focus on major crops and you don't have the intellectual and technical capacity. So the United Nations Food and Agriculture Organization asked me to come up with a plan, and we organized a series of workshops. So we first started conceptualizing the idea, then linking with a number of countries I mentioned in this slide. Then we had an expert consultation workshop, and then we developed the concept, and now it's at the implementation stage. So we had 8 countries: Cambodia, Laos, Myanmar, Nepal, Bangladesh, Bhutan, Vietnam, and India. India is a big country. We chosen West Bengal for various reasons. And that is when the engagement started. We identified, or they identified, crops of importance into their country. Any major crops, we said, keep away from that. It has to be minor crop, but to fit in the 4 concepts I mentioned about the future smart food crops. And this is all published, and I send an executive summary of that to Professor Pampori, and certainly I can send the link for people to download. It's quite a good publication dealing with all these aspects. Now, examples of future smart food. Yeah, let's take, for example, Bhutan. They identified soybean. Soybean, not a main crop in that area, high in protein and good source of essential folate and dietary fiber, flour, soy milk, edible oil. Quinoa, you all know that high fiber, antioxidants, rich in protein, iron, magnesium, and zinc. Lentil, although a major crop in India, it is not a major crop. So it's a minor crop in Bhutan. Then moringa, which is a drumstick plant, which is again coming many parts, significant source of B, C, K, and manganese and iron. The leaves are most nutritious, so as the flowers. Moving on to Lao PDR, they identified fancy yam, good resistant to disease and pests, growing in wet and dry regions. Rice bean, cowpea, and sword bean, all of them they identified from 30 crops, which has the potential and fits in with the definition of the future smart food crop. Moving on, West Bengal, India, swamp taro, again high amount of protein, calcium, vitamin, flood tolerant, and also grows very well during monsoon season. Elephant foot yam, medicinal value, and India is known for that. Reducing bacterial activity when used with antibiotics. Lentils in West Bengal is not a major crop, but it is getting there. Drumstick, which is the moringa I mentioned. Now let us move on my third part of my talk. Nutrition, climate, economic, and social benefit. If it doesn't fit in that, it is not a future smart food crop. So just give you an example. They provide essential micronutrients, high carotenoids and minerals, help address the deficiencies, and enrich diets. For example, if you take a chickpea, it's the same energy as rice, but has got 3 times more protein, 4 times more dietary fiber, 4 times more iron, and look at this, 70 times more folate than rice. This is so important for pregnant women to have a better lifestyle and a good children. I won't go into the mung bean, it is the same. You can see has got 78 times more folate than rice. Then another species which is not grown in your part of the world, lupinus species, it has got 44 times more folate. Now, here is an example. Sri Lanka doesn't grow lentils. So Sri Lanka import lentils from Australia, Canada, India, and also to some from Turkey. This is an intervention study our medical people have done. So the 0 days, and then the assessment was done 60 days. It was for the children, and you can see that percentage improvement in hemoglobin, serum iron, the 74%, then iron binding capacity, which means more iron is available. So that means the figure 6.8% less, or in other words, more iron will be available. Trans ferritin saturation, 89.8%. So if you look at the World Health Organization standard, by simply dietary intervention of giving that lentil to the children to a school meal program or midday meal program, it has improved their iron very substantially. Climate resilient, this is we heard about the land degradation, water depletion, and sloping lands, particularly in places like Kashmir. So we need to have crops which act as a buffer for climate change. For example, soil improvement, particularly the legume crops, increase soil fertility, diversity, and reduce use and cost of fertilizers. Water use efficiency. Some of these crops have got better water use efficiency compared with, for example, corn or wheat. Crop rotation. So, for example, wheat following field pea increased grain yield from 15 to 34%. Break of diseases. So you're not having the monocropping of cereals. The diversification improves the climate resilience as well. High nutrition. The example is mung bean, fast growing, drought tolerant, fits in within the rotation. Bile, growing in wide range of soil conditions and temperatures, greater yam, both wet and dry conditions, and rice bean, easily adapting to various weather conditions and soil types. And also, because of the soil cover, protecting soil erosion. You may know about buckwheat, gluten-free and is suitable for celiacs, contain rutin, a compound that prevents blood from clotting. It can be grown in mountainous region, cold and drought tolerance, fast, short growing, 2 to 4 months, and does well in high elevation, as I mentioned earlier, useful for attracting pollinators, for producing honey, and also better have in your orchards like apple and other areas. And there are example success stories. This is an example from Nepal. It's a total of 300 local varieties of future smart for neglected crops were evaluated, identified and promoted 16,000 farmers in 2018. And community seed banks were established, 4 mountain agricultural systems, 70 locally adapted varieties of amaranth, for example, is a leafy vegetable, beans, finger millet, foxtail millet, and poso millet were identified. And capacity building was given. Reduced drudgery, because we don't want women spending all their time in rice paddy and breaking their back. So here is an example, and there are other examples in the region. Economically viable, that is one of the most important things. So it should contribute to sustainable livelihood, provide broad spectrum of crops, and small scale investment. For example, underutilized and processed products, whether it is in pickles, jams, sauce, many other products we need to look at. So it's a total value adding in the system. And you all know quinoa, how became world famous in every supermarkets in developed countries. It is happening. It's a South American Bolivian family farmers. In the past, they consume a lot. Now with the promotion nowadays, although consumption has gone down, but still consumed. But increased demand globally, increase in informal local trade, more money available, so better living conditions, better education, and better public hygiene. And when FAO said it is the International Year of the Quinoa in 2013, that made a big leap jump in the global market. It's one of the highly demanded product. There's another product called chia and amaranth. All those things are now getting into the main food system. And it must be locally available. There's no point in something which is good, but it can't be grown. So many traditional food systems have healthy elements based on local species, high nutritional value, and contribute to mitigating malnutrition. There is a crucial link for the crop diversity, indigenous food, that is the local farmers' knowledge, and strategies that ensure optimum nutritional status. So the underutilized crop species are still a major source of nutrition for many indigenous communities. Some examples are shown: amaranth, sweet potato, wild honey, rice bean, and in certain areas, small pumpkins. Another one example is from Bhutan. They have identified a number of wild plants. In 5 years of investigation, 108 edible wild species and the 53 families. From there, they distilled into 20 edible wild plants belonging to 5 families. So you know that many formerly neglected crops are now globally significant crop. For example, oil palm was not a mainstream crop. Soybean, you know that it originated in China. Now it's one of the biggest crops in South America and North America, in India as well. Kiwi fruit, everyone knows that came from China. Lupins was from Mediterranean, now it is very popular in Australia. So they contribute to food security, nutrition, dietary and culinary diversification, health and income generation. The fourth part, how do we realize the potential? This is a question always asked. So the challenges are there: social and economic, policy institutional I mentioned earlier, agronomic, not enough information available, and then environmental. So for example, the harvesting is still not agronomically done, processing, production system, marketing, and consumption. A theory of change is important here. A sustainable agri-food system with a policy, increased demand for sustainable products, collaboration with not only government, but NGO organization, and we need a consistent supply of the products and capacity building. And there are things like investment, legislation, and so on, multi-sector investment needed. So you need to look at the holistic thing, why that crop is not taken up, what are the constraints, how can we mainstream it? So how to mainstream? So identification and prioritization, engage the farmer groups, collaborate with the local communities, document and characterize production, encourage local production, dissemination of seed and study, adaptation. For example, a lot of people are interested in the organic agriculture. Some of these things will fit very well in the organic system. Post-harvest processing, improved technology, trade and marketing. You saw how widely now quinoa or chia, and these are taken. That's basically marketing. Develop market-oriented strategies, improve value chains, branding, and novel food items. People are concerned about health. So people are not interested in going to the doctor and getting a pill. If you have the whole food, that's how the globe is going to drive. So your medical doctors are going to prescribe you the food you have to eat at a young age, middle age, old age, not about going on the supplement. Consumption, dissemination of information, nutritional awareness, education, and cooking methods. You got a lot of fallow lands in India. If you look at the fallow lands in the Indo-Gangetic plain after the rice harvest, and just an example to show that the government of India has started to fill that fallow land with a number of crops and schemes. I won't go into the details. 4,000 villages of 40 districts in 6 states has been allocated a target for bringing that fallow with suitable crops. For example, the cereal-based system with a legume crop, for example, diversification such as lentil or field pea short crops and chickpea can really expansion in the rice fallow system. And there is market opportunities, rural income, and building capacity through agricultural extension services required. There's another one from West Bengal. So you got rice in July, October, and they're bringing lentils into the system and mung beans and sesame into the system, which can help to that food diversification, market diversification, system diversification. And marketing and consumption, you can promote, but also I'm very interested to see this Akshay Patra from India. I think they are based in a number of parts, but somewhere in Bangalore, the school children's lunch program, midday meal program. If you go to some of the things like pulses, millets, cereals, vegetables, or even fruit, etc., can make a huge difference in integrating the recipes to improve the nutritional status of the school children and also and the mothers and the lactating women. I'm coming to the end of my talk, but the holistic approach is needed. So to start with, we need to look at the genetic diversity within the country or the region. We could immediately go and selection cultivation. We don't need to start breeding right away. Then we need to harvest and value addition, marketing, as I mentioned earlier, the final use, and it should have an impact on improved nutrition, income, and other livelihood benefits. And there is a number of things. Their outcome is self-esteem, empowerment of communities, and I won't go into all the details, but basically you need to look at this pipeline, but there are things like improved technology, efficient value chain, etc., can add into that. Much of this is already covered in this book, and Professor Pambori, I'm happy to provide a copy of the book. I already gave you the executive summary of that. We also done a similar exercise with mountain agriculture because Kashmir is in the valley and the mountain area. There's a lot of wealth of information in integrating some of these so-called future smart food in the mountain system. That's also available with the FAO website. So my conclusions, I hope I haven't taken a lot of your time. The current food and agricultural system, multifaceted challenges. We need to promote agriculture diversification. It is essential to address the current agriculture and food system, not only the farming system, but the food system. The so-called Future Smart Food, FSF, provides nutritional, I mentioned already, climate, economic, and social potential to develop a diversified and sustainable food system for a better livelihood locally, regionally, and nationally. And we need to have a holistic and a sustainable value chain development. The multiple benefits has to be harnessed. And government still has got a role to play, key leadership. But we cannot rely entirely on government. We have to have private investment. We have to have the NGOs, the farmer groups, etc. And with that, I believe that it is possible to make a transformation in the agricultural system in order to address the soil health and environmental health, but also the human health. Thank you.